So this is our last little application of factoring polynomials. We're going to talk about how we solve or solving polynomials in this short video. So the first few examples, we're going to look at how to solve an equation that looks like our example here in example 1, the quantity x minus 5 times quantity x plus 4 set equal to 0. Now what the answers are being called in this situation, they're called solutions, roots, zeros, or x-intercepts. All four of these terms in mathematics are all synonyms for this exact same thing, which is when you set x or your variable equal to a number or a solution, root, zero, or x-intercept in this case. So when we look at the following equation, if I want to solve and see where these two expressions are going to equal 0, we need to think about a number that I could plug in for x that would make this entire expression equal to 0, because the solution truly is making an equation true. So if I can think of a number that I can plug into that's going to make this equation true, that will be my solution. So the first thing that I might want to try or look at is actually looking at what would make this individual expression, x minus 5, equal to 0. Because if you think about it this way, if I can make this piece of the product equal to 0, 0 times anything is always going to be 0, because 0 times anything is 0. It's probably my zero product kind of property there. Anything times a is going to be 0, any type of number. So what would make x minus 5 equal to 0? Well, that would be x equals 5. So if that's true for one piece of my product, wouldn't that also be true for the second piece of my product? So if I would go ahead and subtract 4 from both sides, x would also probably equal negative 4. So 5 and negative 4 are both solutions, roots, zeros, and x-intercepts. So if we follow that same logic here for our other examples, if I take x plus 6 set equals 0 and I do x minus 3 equals 0, both x equaling negative 6 and positive 3 would represent solutions to my equation. Here I have x plus 2 squared raised to the 0 power. So whenever I square a number, okay, if I want to see where a squared is equal to 0, ultimately if I know it when a is equal to 0, then when I square that, it will also be equal to 0, because anything 0 squared is still 0. So if I can go ahead and set x plus 2 equal to 0 and find that value at negative 2, that would also make the entire squared function also a 0 at negative 2. Same thing here, set your parts equal to 0. So my first piece of the product is x. Well, that's easy, x equals 0. The other piece is going to be at x equals negative 2, and both these values would represent my solutions. Same thing true would be here, 3x plus 10 and x minus 2. When I set them equal to 0 and solve, this one comes out to a nice easy 2. However, this one's kind of a two-step problem. To solve for x, I'm going to first subtract 10 to both sides. Then I'm going to go ahead and divide, since it's a product, I'm going to divide by 3. So my other solution is at a negative 10 thirds, written in fraction form. So why are we doing this, and why are we trying to find solutions, roots, zeros, and x-intercepts for these types of factored equations? Well, let's go ahead then and kind of backtrack and go back to what we talked about in the previous lessons, which is how do we factor something completely. Last couple of lessons in class, we've been talking about different methods on factoring. The ways we can factor are factoring our GCF. We could also recognize the pattern of dots. And we also have trinomial grouping, or I also showed you the box method, which I'm quickly falling in love with because it's just a great alternative method when it comes to factoring trinomials. So we have 3 different ways we can factor, always looking for these first, and once I factor it, it becomes very similar to what we did up through example 5, is setting each factor equal to 0 using the zero product property, and then solving for that x. So what makes this different from factoring is now I have this equals 0, and the only way I can factor is when I have an expression set equal to 0. So here I have x squared plus 8x plus 15. I have a trinomial. All the terms are different. A is 1, B is 8, and C is 15, just recognizing that pattern. So I'm going to go ahead and multiply A times C and get 15. And I'm going to look at what two numbers multiply 15 but add to 8. So the two factors that pop up to my mind for 15 are 5 and 3. And 5 and 3 also add to 8. So you could factor by grouping. You would get x squared plus 5x plus 3x plus 15. You could split it up and then find your common factors. You also have this cool box method, which allows you to draw a square, write your four terms in this specific order. And then look for common factors. No matter your method that which you pick, that's fine. I'm going to keep practicing my box method because it's new to me. Bring down the x, bring over to positive 5 for the common factor. Upwards here I have a common factor of x. And in the second column I have a common factor of positive 3. So here my two factors are going to be x plus 5 and x plus 3. I can always check my work by FOILing. Now remember, what makes this problem different from what we've done in the past is we've stopped right here and we've said, hey, I factored, I'm done. But now I have multiple steps. Now I have to set my factors equal to 0, the original equal 0 that I was given in my problem. So by setting both of the factors equal to 0, I'm determining where this function, where this polynomial overall is equal to 0. And those two values would occur at x equals negative 5, also at negative 3. Now, what makes these zeros, intercepts, roots, is if I would plug negative 5 and negative 3 back into the original x values, what would happen is I would get a expression that is actually equivalent or equal to 0. And that's why it's called a 0 as well. We're looking here at example 2 now. This is a little different than what you saw in example 1, mainly the fact that I have things on both sides of my equal sign. And the first thing you want to do whenever you're factoring and using the zero product property is being able to set your function equal to a 0. So right now I don't have a 0 on one side. I do have a b squared on the left hand side, which is positive, and I like that, so I'm going to keep him there. I want to take b squared and negative 10, and I want to bring them to the left-hand side of the equation to do that. To do that, I'm going to go ahead and subtract or add their opposites, because by the addition property, the additive identity is the inverse of those terms. So 8b minus 8b cancels out to 0. But I also, what I do to the left, I have to do to the right, I have to do to the left. No like terms, so he's going to stay right there. Negative 10 plus 10, they cancel out and become 0. And I'm going to also add 10 to the 5 that's on the left-hand side. 15 plus 10, well that is, 5 plus 10, which is 15. Now on the right-hand side of my equation, I have an equal sign. So now that I've moved all my terms to one side and combined like terms and set equal to 0, now I can factor and use my zero product property. So again, looking for two numbers that multiply to 15, but add now to a negative 8. Well, that's similar to example 1, but now my factors are both going to be negative, because they add to a negative 8. And now I'm going to go ahead and factor, and let's factor by grouping just so we can practice that method as well. I'm going to draw my line. I'm going to take out my common factor of b in the front. I'm going to take out my common factor of negative 3 in the back. And my common factor overall now is a b minus 5, and that's being multiplied to a b minus 3. Now, again, we're not done. That's only step 1. But now that I've set it equal to 0, I can now solve by setting each of those terms equal to 0. So b minus 5 equal to 0, b minus 3 equal to 0. And rather than subtracting, I'm going to add 5 and 3 to their respective equations. So my two solutions, roots, zeros, or x-intercepts, are going to be positive 5 and a positive 3. Sometimes you'll see teachers kind of put brackets surrounding their solutions to represent that those are my solutions or zeros. So keep that aware as well. Okay. Now we do have some other example problems throughout the notes. So go ahead and take your time and try some of these problems. Okay. As you're going through those, make sure you're recognizing when am I factoring or when am I solving. It's very important to understand that, for example, number 3, I'm only asked to factor because there is no equal sign. Nowhere do I see an equal sign. Same thing with 4. What makes 5 different is I'm solving here because I do have an equal sign. So go ahead and try these problems. Check them with the key that will be posted online. And if you have any questions, you come in and see me, and we can talk about how to factor and solve. Thanks.